Hey guys, welcome back into our segment routing training series. In the last episode, we went ahead and did the hands-on around the segment routing, and we went ahead and learned the concept of explicit path. In that episode, we went ahead and created a couple of our segment lists, and using those segment lists, we had created a path or a policy from our PE1 to our PE3. So when we learned about, then we had learned about another type that we could use for our path, and that was the dynamic path. The explicit path, gives you the flexibility when you are creating a policy. Hey, you want to make sure that this is the path I'm always interested into. At the same time, we learned there was some drawback. Let's say on that path, if that node fails or one of the link go down, then your policy becomes invalid and the policy will go down. And around those things, we had learned the concept of dynamic paths. So in the dynamic path, the overall concept, there were two things, if you recall. There was something called an optimization objective, and the another thing that was in the dynamic path was the constraint. So these are the two things that would be, play a big role when we are creating a dynamic path. So when we are creating a dynamic path would rely on your underlying either IGP, IBGP, or EBGP, whatever your underlying protocol that you are using to figure out the path from a given endpoint to the another endpoint. And the endpoint where we go ahead and create those policy, if you recall, we were calling them what? Yes, if you guessed headend, yeah, those are called as your headend routers, and the destinations are called as your endpoints. And to signify the policy between those pair of devices, we were using a numerical value, and that numerical value we are calling a color. So the thing with the color was that it needs to be unique within a given pair. So you could go ahead and use the same color on a different pair, but within the same pair we cannot repeat or reuse the same color value. So in this episode we will go ahead and now take a look or create the policies with the help of the dynamic path, and we'll go ahead and take a look at some of the things here. When we create any policy with dynamic path or anything, there are a couple things that plays a role. There are different type of metrics that really plays a role, which are simply called as your metric, METRIC. We have a traffic engineering metric, we have an IGP metric, and we have a delay as one of the potential metric. So by default, if you just turn segment routing, all of these values have a value of really 1. And when we don't configure delay, you might not see even any value over there. So right now, this is our default topology. And in this topology, all the links has a IGP metric of 1 as well as a TE metric of 1. And if you need to really verify, you can go to any of the node and you can go ahead and simply run the command show MPLS traffic engineering topology. And when you go ahead and run that command, if you just take a look at in this command, it says, hey, this particular node, the node in this case is PE1, it's neighbor with this guy, and there is a link. The link is point-to-point link. This is my IGP neighbor. And if you take a look at on that neighbor, the third line that says TE metric and IGP metric. So right now with that neighbor, our TE metric has a value of 1, as well as the IGP metric has a value of 1. And if you take a look at here, delay metrics, it clearly says right now not present because we have not configured any kind of delay. Again, we can go ahead and run the same command on any of the node in this topology to figure it out. Now let's just go to the node P4 and we'll go ahead and verify what is the TE metric, what is the IGP metric there. So now let's go to P4, show segment routing, traffic engineering, and topology. Not segment routing, show MPLS traffic engineering topology. And again, it says, hey, I am neighbor with one of this device, and there the TE metric and IGP metric is 1, and there is no delay metric is being present right now. So that's how we can go ahead and see that all of the node in the topology has a default metric of 1 and 1. So now, keeping these topology, that means if you go ahead and create a policy, this PE, let's say we want to create a policy between again PE1 and PE3. That means the PE1, if I go with an IGP, let's say I want to go ahead and create a policy based on the IGP metric, or the IGP, That means this PE node has two potential paths to reach PE3, which are of equal cost in this case. Either PE1 can go to PE3, from there PE3 to P4, and from P4 to PE3. The another path is from PE1 to P1, P1 to P2, and P2 to PE3. So these are the two equal cost paths, and you can see our head end or the policy can pick any of the path, because in this case both of those links have a similar metric. And if we go ahead and look at the IGP, and that means we are saying, okay, hey, look at the least number of nodes. So this path would have the least number of nodes, and if you take a look here, 1, 2, 3, 4. If I go different path 1, 2, 3, 4, and 5, so this is a longer path. So our policy probably will not pick this one. Similarly, if you go the top path 1, 2, 3, 4, and 5, again this is not a valid path or a good path. So our policy will go ahead and probably pick either this path or one of this particular path. And again, we will be able to verify some of the things. So now let's go ahead and see. We will go ahead and create our policy, a SRTE policy, using the dynamic path. And in this case, we will go ahead and create a policy based on the IGP metric. So now we are on PE1. PE1 is our head-end router. So now let's go into the configure mode. And within the configure mode, anytime we have to configure a policy, we need to go under where? Yes, segment routing, traffic engineering. So now let's go to say segment routing, traffic engineering. There we can go ahead and create a policy. The very first thing we have to give a policy a name. Let's call it our policy. We'll say SRTE underscore policy based on, let's say, IGP. Now there are a couple of options that we can go ahead and do that. Again, you can press a question mark and take a look at what are the different options that are available to us. The very first thing we need to pick is a color. So let's go ahead and give it a color. I'm just going to assign a color value of 10. Once the color is done, the next thing you would have to give an endpoint. Endpoint in this case is the destination. Let's say we are creating a policy to reach from PE1 to PE3. So in that case, PE3 will be our endpoint or the head end or the tail end sometime. Not the head end, I'm sorry, I said head end. So it's going to be the tail end or an endpoint. Means this is your destination. So now let's go ahead and say endpoint, and now we need to go ahead and give an IP address. So in this case, we are using an IPv4 address, and the IPv4 address in this case, we are using the loopback address of this particular router. So which is 192.168.0.7. Now, once that is done, so we went ahead and created a policy. We gave a color, we gave an endpoint. Now, the important thing in a policy is really the path, and which comes under your candidate paths. And you can have multiple candidate paths, as we saw in the case of explicit. So now we'll go ahead and do the same thing. Hey, we are doing a candidate paths. Now, if you recall, every path had a preference. If you had multiple paths, higher the preference, better the path. So it can go ahead and pick any of those paths. So now let's go ahead and say give a preference value here. We'll say preference of 100 in this case. Now once you inside the preference, if you see there are a couple options here, and one of the option you would notice here, it says dynamic, which is dynamically allocated path, and that's what we are interested in. In the last episode, we had used the explicit path. We went ahead and gave the path that we had configured. But now we are asking, hey, I would like to use a dynamic path for this policy. So now we'll go ahead and say dynamic here. So once you do the dynamic, there are a couple things that are being presented here. And one of the things that again we are interested right now is the metric, which is path metric configuration. When you're trying to figure out a path, what kind of a metric based on that you want segment routing to figure out a path for you. And that's what we go ahead and define with the help of a metric. So let's go inside the metric, and if you press a question mark here, there are a couple things that we can go ahead and do that. And now out of these options, if you pay attention here, we have there's something called type, which clearly says metric type configuration. Hey, what type of metric you want? So now we have to say type, and with the type, if you press a question mark, there are a couple options that we can see. Hey, we can have a metric type of hop count, means number of hops in a given path, or we can have a path based on IGP, which is IGP metric type, and as we saw that both the TE and IGP metric are 1 right now. we can have a type based on the latency. We can say, hey, pick a path based on the lowest latency, or we can have a path based on the TE metric type. So in this case, we will go ahead and start with IGP, the simplest one. So now I'll go ahead and say, okay, hey, the metric type is IGP here. And that will be all. So let me go ahead and commit the configuration. And now let's just come out from here and I will show you what all we went ahead and wrote. So show segment routing traffic engineering here. Now what we just did here, if you notice here, we went inside segment routing traffic engineering. We created a policy with the help of a keyword policy. We gave our policy a name. And then for this policy, we went ahead and picked up an color, which is a numerical value, and the endpoint, which is our destination or tail end that we want to reach. And this policy is being configured for PE1. So PE1 is our head end router. If you recall, a policy had three elements: H, which is your head point, C, which is the color, in this case 10, and HCE. E is your endpoint. So in this case, the endpoint or tail end is 192.168.0.7, which is your PE3 router. Now, once that is defined for a policy, there can be one path or multiple paths. So we are saying, okay, here the candidate paths, and for this candidate path, the preference is 100. I am not using multiple path right now because we do have multiple path. In case one of the path will go down, our policy will be able to use the another path. So I don't have to go ahead and really add another path. But if you want, yes, you can go ahead and do that. And now for that path, we are saying, okay, it's a dynamic path. The metric for that path is being in the type of the metric is really the IGP. And that's the thing. Now we went ahead and created a policy where we are saying, okay, head end, it is your responsibility to calculate a path from yourself, means from PE1 to PE3, because that is our endpoint, based on IGP. So the path calculation work has been given to this PE1. That means this is PE1's responsibility to always figure out a path for this particular policy. Okay. Now, once the policy is configured, now let's go ahead and take a look at what is the status of our policy. So we can go ahead and do that. And if you recall the command, we learned all these commands in the last episode also. So we'll say show segment routing, traffic engineering, and policy. Let's go ahead and press a couple space bars here. Now, if you take a look at here, what it says right now, hey, this is the, again, this is our SRTE database, SRTEDB, and this gets populated with the help of what? If you guys recall, yes, the distribute link state command from your IGP. Now the color is 10, and this is our endpoint, and this is the name of your policy. Now if you take a look at, okay, here the policy is admin up as well as the operationally is up. That means PE1 was successful in finding or able to calculate a path from PE1 to PE3, and it was able to figure it out all the path, and that is why our policy is operationally up. Now the candidate path in this policy says that for the preference for that path is 100 configuration, and that path is right now active. This is the name of the policy that we had configured. Again, the binding SID is being allocated based on a dynamic. We are not giving a static binding SID. And PCC, your head end is also called as your PCC, Path Computation Client. So PCC stands for Path Computation Client, also known as head end simply. So head end or PCC is a similar thing. People just use these words interchangeably. Sometime you will hear head end, sometime you will see PCC. So in this case, this is the PCC information, and this is your some ID. Now if you take a look at here, the main thing, it says a dynamic and it's a valid, and the metric type that is being used here is IGP. And for this IGP metric, the total or accumulated metric is 3 here, because recall the path that it was really taking, there were only 3 hops. So similarly on this we have 3 hops, here we have 3 hops, that's why the total metric is 3. And you would see 16,003. If you recall, this is the global prefix SID for PE3 router, and that's what it says. Okay, here prefix SID 3, and that is the binding SID that is being allocated for this particular policy, 24,005 in this particular case. Now once the policy gets configured, if you take a look at here, if you do like show IP interface brief, you would see that policy is being shown as one of the interface into our interface table. So now you could use this to, you can create static route and use this as one of your outgoing interface to send some traffic to this particular node over the SRTE path. And in this case, the path that is being used or figured out based on the IGP is as simple as primarily that much. Now there are a few more other commands that we can go ahead and run here, a pretty cool command. So let's take a look at here. Let's do something else before that. So if we do show MPLS forwarding, and in the forwarding, if you take a look at the binding SID is 24,005 right now, and that's what you see here. We have a binding SID of 24,005. There is no prefix SID, and the outgoing interface for is this particular one, which is a point-to-point interface now. And again, we can do a few more things here. Show MPLS forwarding, and if you recall, we had a few things. One of the things was label, and the label that we are interested into is right now 24,005. And again, we can go ahead and do here some details for that particular label. And it says, okay, hey, for this label, it is being popped. The outgoing interface is our policy. And for that one, if you can see here, the outgoing interface for this one is this particular policy. And you can run all the other commands that we ran into the previous episode actually. Now the command that I want to really show you here in this one is the show segment routing, traffic engineering. And if you recall, we are working on PCC. So with the PCC, we can go ahead and do an LSP here. LSP stands for your link state information. So now if you go ahead and just simply press and enter here. So now we are taking a look at inside our SRTE database. That's what it says, PCC's SR policy database. And for this policy, hey, this is our LSP number 0. The source in this case is 0.5. That is PE1 routers loopback 0. The destination is 0.7, which is your endpoint's IP address. There is the ID for that tunnel is tunnel 0. LSP ID is 1 here. And the state for that is admin up and operational is up. The setup type, that is SR segment routing. The other type you could have, let's say if you're using RSVP or something. And in this case, you would see the same binding SID. So in this case, the binding SID is 24,005. Now, if you take a look at here, if we do a show Ceph 192.168.0.7/32, you can see, okay, hey, to reach this, there are two ways that it can be reached, either via interface 0 or either interface via 1. That means if any of the interface goes down, let's say if this interface goes down, our policy will continue to stay up because there is another path, and the system will go ahead and use that particular path to reach from PE1 to PE3. Again, we can just go ahead and take a look at one more time at our policy. And as you can see, the policy is currently up right now. And just to prove the point, let's go ahead and simply, I'm going to go ahead and let's say shut down this interface. Or we can shut down an interface, but let's say I'm going to shut down the interface on PE1, let's say interface gig 01. So now we go into interface gigabit ethernet 001. And if I do a shut on that interface, and now if you come back quickly, take a look at our policy. Our policy is still up because if you remember, our policy had two paths. So if you take a look at the show Ceph, right now it says, okay, hey, to reach this one, the path that is being utilized is 000. If you go ahead and shut the 0 interface also, yes, in that case, the policy will go down because then it has no way of reaching, and we can go ahead and prove that also. So now just simply go ahead and shut down the interface 0. And let's take a look at our policy again. Ceph, obviously, hey, there is nothing in that. So now verify, look at the start of a policy in this case. And you can see the policy is definitely admin up, but operationally it is down because it is not able to find a path. So it clearly says a no path found, and dynamic is invalid, and that's why we don't see any information over here. And again, just to simply bring it back, let's go ahead and bring back the interface 1 first this time. And we'll just do a simply no shut. And if you verify show segment routing, show segment routing traffic engineering policy, Now you can see our policy is again up and it was able to figure it out a path. Now let's just go ahead and bring it back our interface gigabit 0 also. So that way we have multiple paths here. So that kind of, so you see the advantages of the dynamic path really, or when you use the dynamic path-based policy. That way, if one of both the path go down, we didn't have to take any action for our policy. Our policy was able to figure it out, or the PCC was able to figure out the path or an alternate path to reach the destination or the endpoint. So that'll be all for this episode. I will see you guys in next episode. And again, yes, please do a lot of hands-on. That's how you're going to learn about this technology. Thank you, and I will see you in next episode. Bye-bye for now.